You can make all these shapes using just these two tools. And behind these beautiful patterns are some basic constructions which we are going to learn today. But before that, let me tell you something about these tools. Using a straight edge, you can draw only straight lines. And using a compass, we can make circles and arcs. You cannot use them to measure lengths or angles. Let's begin our constructions. Here's an angle. How can we draw its angle bisector? That is, drawing a line which divides the angle in half. Let's start. Using the vertex as the center, draw an arc intersecting the arms of this angle. Now from these 2 points, draw 2 arcs with equal radii. And that's the angle bisector. Why? These 2 lengths are the radius of this arc, so they must be equal. And these 2 arcs have equal radii, so these 2 lengths must also be equal. Now if we fold this shape, aligning these 2 equal sides, we get 2 perfectly overlapping triangles, which means these 2 angles must be equal. By the way, if you are familiar with congruence rules, then these 2 triangles are congruent because all 3 of their sides are respectively equal. Hence, these 2 corresponding angles are also equal. Here's a line segment. How can we draw its perpendicular bisector? It is a line that divides this segment in half at right angles. Let's use our tools. Using a radius greater than half the line's length, draw arcs from each end. Repeat on the opposite side, and that's the perpendicular bisector. But why does this work? Since we use the same radius for all 4 arcs, all these 4 segments must be equal. If we fold this shape, aligning these 2 equal sides, we get 2 perfectly overlapping triangles with equal angles. Now in these 2 smaller triangles, these 2 sides and the included angle are equal, so these 2 triangles must be congruent, which means these 2 lengths and these 2 angles are equal. Since the equal angles sum to 180 degrees, each must measure 90 degrees. So we get perpendicular bisector and we are done. In fact, if we take a different radius on the opposite sides, the construction would still work because again by symmetry, these 2 angles are 90 degrees each and these 2 lengths are equal, making this line the perpendicular bisector of this segment. Now what if we have a random point and we want to drop a perpendicular from it to this line? Can you think of how to draw it? We'll use the same idea of drawing a kite shape. Here's how. Using this point as the center, draw an arc that intersects this line. Now from these 2 points, draw 2 intersecting arcs of equal radii. Now you already know why this line must be the perpendicular of this line. These 2 lines are equal to the radius of this arc and these 2 lines are also equal. So, these 2 triangles perfectly overlap, making these 2 equal angles. Since they together make a straight angle, the line must be at right angles to this line. Now here's a challenge for you. Say we have a line segment. How can we draw an equilateral triangle whose sides match its length? How about a square? Remember, you can only use these 2 tools. In fact, you can even make this beautiful pattern using only angle bisectors. Try it and let us know your approach in the comments.